right, so that was from yesterday. Whenever the sign and the increasing or decreasing are working together, then that distance is increasing. Whenever they're working against each other, then that distance is decreasing. So positive increasing working together, negative decreasing working together. All right, so that was from yesterday. But from the previous lessons, like earlier in the year, we learned that when a function changes from increasing to decreasing, it creates a relative maximum. And when a function changes from decreasing to increasing, it creates a relative minimum. Now that doesn't translate to look the same on a polar axis like it does on a rectangular axis. So it's a little bit more difficult to get from the graph. It's easier to think of, is that R value increasing or decreasing? Okay, we are going to split up the work on this table. I'm going to give you each an angle, and you are going to plug your angle into this function. And you have your unit circle right in front of you, and get an answer. Now your answers are going to be integers, so no like weird fractions or decimals. Nope, no calculator today. Just use your unit circle. So you're just plugging your angle in, finding the cosine of it from your unit circle. Whatever you get, multiply by 4, and then add -2 to it, or subtract 2 from it. You can do it. Everybody can do it. Have complete faith.
You said you multiply by 4 and what?
You're going to multiply whatever you get for the cosine by 4, and then subtract 2 from it.
Subtract.
Mm-hmm. Okay, so who had 0 to plug in? Or just tell me what you got. If you had 0, what'd you get? Okay, we'll come back. All right, if you had pi over 3, what'd you get?
0.
Yes. Pi over 2? What'd you get when you got the cosine? You got 0, right? Yes. 4 minus 2 is definitely 2. Is that what you got?
Yeah, I got 2.
That's right. All right. 2 pi over 3? Yes. Pi? Yes. 4 pi over 3? Yes. 3 pi over 2? Yes. 5 pi over 3? Good. And 2 pi? Nice job, everybody. Okay. And so this first question is not asking if the distance is increasing. It's asking the function, if the function values are this r. So on what intervals is the function increasing, or are the r's getting bigger and bigger and bigger? Between what and what? Yes, this is increasing. Okay, so I'm going to write it a little differently than yesterday. We're going to say is pi is less than or equal to theta is less than or equal to 2 pi. Now, yesterday we didn't include the endpoints because those endpoints were approximations. But today we are going to include the endpoints because they are exact values. not going to matter a ton for you guys in the AP exam. They're not going to switch it up on the answer choices, and this is only going to be on the multiple choice, so you're fine. If you take calculus next year, we'll go into a little bit more detail about why, but we're not going to worry about it this year. We're just going to learn what we need to learn. All right, and then we're the R values, or the F, is decreasing from 0 less than or equal to theta less than or equal to pi. All right, so at this point right here, the function changes from decreasing to increasing. So what should be there? Relative minimum. Now let's be careful that we try to remember how polar coordinates are. So polar coordinates are r theta. So I know on our table we do it backwards. That's just because of the way the independent and dependent variables are. But when we do polar coordinates, we do the r first and then the theta. I kind of wish it was the other way, but it's not. Okay, and then E and F are talking about what we learned yesterday, or this first table up here. And so we want to find the intervals of theta where the distance between the function and the origin is increasing. So what are we looking for increasing? Right, positive increasing, negative decreasing. So that should happen twice, I think. All right, so negative, we are going to include 0. So 0, we're thinking about it as positive or negative to answer these questions. So right here is one of those intervals. So that's the negative decreasing. All right, and then positive increasing. Again, we're going to think of 0 being either. This is our other interval, so from 5 pi over 3 to 2 pi. Right, and then all the other intervals are going to be decreasing intervals, but what we're looking for is either positive decreasing, so here, or negative increasing, so there. All right. So we did the stuff we did yesterday without the calculator, and it wasn't terrible. From what I've seen on the multiple choice questions on the non-calculator, they ask them in a way that you don't have to plug in a million points. So I'll show you what I'm talking about when we get to example 3. So it's very doable. They really just want you to know the rules and be able to plug in a few points. All right, example 2, we have a table. And this table gives us intervals of theta and where the function is increasing, where the function is decreasing, and then certain points on the graph. And what they're asking us to do is identify any relative extremum, or the relative max and the relative minimum. And so what we're looking for is where the function is changing from increasing to decreasing or decreasing to increasing, which it does change here. So what is that going to make this point be? Yes. And don't forget, we do the R first and the theta second. That's not going to matter on the multiple choice questions. They'll be in the right order, but it's fine. Okay. And then the next interval is also decreasing. So that doesn't make this point be a relative max or min. So we're just going to skip it. All right. And then we're changing from decreasing to increasing. So this is going to be a relative extrema. Which type? Min. All right, and then increasing to increasing could be a point of inflection maybe, but it's not going to be extrema. But increasing to decreasing, we have another relative maximum. Okay. So that's how you kind of interpret those tables. All right. And then example 3, we have a polar function. What type of polar function is that? The one nobody wants to say. A Limachon. And it's going to have an inner loop because it's less than I told all my third period year little trick. They figured out who it was. I didn't say who it was, and they're like, that sounds like something Jonathan would say. I'm like, it was him. All right. So anyway, we have this polar graphed in the polar system from 0 to 2 pi, and we want to know which of the following statements is true about the distance between the point and the origin. Now, we end up with 2 different intervals, which isn't terrible because you've been dealing with 4 different intervals, but let's see if we can narrow down some answer choices. So A says the distance is increasing because f of theta is positive and increasing. Could that be an answer choice? Yes. All right, B says decreasing because positive and decreasing. Could that be an answer choice? Yes. C says increasing because negative increasing. Could that be an answer choice? No. What about D? No. And so that works out really nice because the only interval that we're going to have to check is from 0 to pi over 2. The other one is not going to be an answer to this. So I need to plug in 0 for theta and pi over 2 and see if I get a situation that's positive increasing or positive decreasing. All right. And so when I plug those in, you guys look like you're already doing it. All right. So I really hope you guys know, like for a long time, that the cosine of 0 is 1. Like I hope that sticks in your head. The cosine of 0 is 1. So that would be 4 plus 2, which is 6. And I'm pretty sure this is going to have to be decreasing because the farthest out that you're going to get is when you add these two, which is 6. So, but let's just go ahead and plug in to make sure we didn't mess something up. All right, cosine of pi over 2 is 0, so that's going to give us 2. So what do you guys think? Which choice? B. Definitely positive and decreasing, which is what this says. And that definitely means the distance is decreasing. So it's not terrible. You should be able to eliminate a region or an interval and just check 1. All right, and then for example 4, we know that this function, the distance of this function and the origin is increasing on that interval. We don't know what the function is. It's fine. We don't need to. Which is true? Which one of these 4 things or 2 of these 4 things is true about that interval if the distance is increasing? You guys take a second and figure it out for yourself. It could be 1 or 2 of these things. What do y'all think? It's E. It should be for increasing, positive increasing, or negative decreasing. So there's lots of ways that you can be tested on just knowing the rule and not actually doing the work. All right, what questions do you guys have?